Hello students, welcome back to A-Star Tuition channel. Today, we will continue our discussion about kinematics, which is the part 3 of the video. Today, we will discuss about two-dimensional motion, whereas in the previous two videos, we only focus on one-dimensional motion. So let's just get started. When we talk about two-dimensional motion, there are two most common examples. Which one is called the projectile motion, and the other is called circular motion. Today, we will restrict our discussion to projectile motion only, as circular motion is usually dealt with, we need to use the concept of forces a lot. So we will defer this discussion for later. Let's talk about projectile motion. Now, what is projectile motion? So, the example of projectile motion is this. So, let's say that you have a particle, let's say a small particle like a small rock that you throw at an angle. Let's say the angle is alpha with respect to the horizontal line. And then you can see that the particle will move according to a parabolic trajectory. So that's the reason why sometimes a projectile motion is called parabolic motion, because the path of motion is that of parabola. Now, you can see here that this motion is two-dimensional, because you can see that as the object moves through this path, there are two directions in which the objects moving. Okay, so you can see that the one direction is the sideways direction or the horizontal motion, and there's also up and down motion like this. Yeah, so this is the vertical motion. So even though the object itself moves concurrently in horizontal and vertical direction, you can actually analyze the horizontal motion and the vertical motion separately. In fact, the only quantity that connects the two variables here are the time variable. Now let's look at the horizontal motion. Now, for the horizontal motion, you can see that there is no acceleration. Yeah? So you throw a particle, but then there is no acceleration at all in the horizontal direction. So in that case, we said that the motion is uniform. The one that we discussed in the previous video, uniform motion is the one with no acceleration. So then let me write down here for the horizontal motion, the fact about the horizontal motion, which is that it is a uniform motion. Okay? In other words, the acceleration 0, and that the final velocity is equal to the initial velocity. Now, please understand that because we will have two components, the vertical and the horizontal, it is actually very customary for us to use like a subscript to distinguish between those two variables. So here let me write down a subscript of x and x here. So Vx equal to ux. What does it mean? It means that the final horizontal velocity is equal to initial horizontal velocity. Now if this is the case, then we can find the displacement easily by using Vx times t or ux times t. Now, what is ux? Now, ux is, as I mentioned earlier, is the horizontal component of initial velocity. So that initial velocity is this. So, if this is the path of motion, so you can see that the velocity is always tangent to the path. So, initially, this is the direction of the velocity vector. So, this is u. Now, u here has two components. Now, as we talk about in vectors, we can always resolve factors into components. Now, when we resolve u in the sideways direction or the horizontal direction, we can see that the magnitude of the horizontal component of initial velocity is u cosine alpha, whereas this is equal to ux. But then on the other hand, you also have the vertical component of the initial velocity, which is u sine alpha. Yeah, so this is uy. So therefore, here we can write down that Vx is equal to ux is equal to u cosine alpha, and this is u cosine alpha times t. Please remember how we define alpha. So alpha is defined as the angle between initial velocity and the positive horizontal axis. So let me write it down. Angle between the initial velocity and the positive horizontal axis. Okay, now this is the horizontal motion. Now what about the vertical motion? Now hold on, let me just erase this a bit. Now when we talk about vertical motion, remember that in the previous video we discussed a bit that a vertical motion is the one that's affected by gravity, but it's also uniformly accelerated, meaning that it has a constant acceleration. In fact, here we say that, okay, let me characterize this as this is a uniformly accelerated motion due to gravity. Now, so then the A is equal to minus G. Yeah. Now, what about the velocity at later time? The velocity, the vertical velocity at later time is related to the velocity at initial time by this equation, uy minus gt. Yeah. So hopefully you remember this from the previous video. And uy is, as I draw here earlier, uy is simply the vertical component of the initial velocity, which has a magnitude of u sine alpha. So Vy equal to u sine alpha minus gt. Yeah. Now you can see here that the velocity, the vertical component of the velocity, is actually not constant, unlike the horizontal motion. Yeah, it's a function of time, linear function of time. So then, when you look at this and you try to graph it, let's say Vy function t, you should observe something like this. Yeah. Now you can see that initially the Vy is positive, and the reason is because you throw it at an angle above the horizontal. But if you start from throwing it at an angle below the horizontal, then the starting point would have been negative. Yeah, please understand that. Yeah. So in this case, it's positive because the alpha is above the horizontal. Now, what about the displacement? Now, the equation for displacement for your uniformly accelerated motion, as discussed in the previous video, is uyt minus half gt squared. Then, we also write as u sine alpha t minus half gt squared. Okay, now that you understand the horizontal aspect of the motion as well as the vertical aspect of the motion, what about the velocity at any instant? What I mean by the velocity, I mean both the magnitude and the direction. Let's say here at this point, let's say that we know the time. At this point, the time is, such and such value, for instance. Now, we can obviously calculate the the horizontal component of the velocity, which is actually does not depend on time, so we can calculate at any time. But for the vertical component of velocity, we actually need this information regarding the time. So once you get that, Vx and Vy, we can actually calculate the magnitude of the velocity factor, which is essentially the speed. Yeah? So the speed. So this is the velocity at this point. Okay, the velocity. So the speed, which is equal to the magnitude of the velocity factor, can be found by taking the square root of Vx squared plus Vy squared. And the reason we can do that is because both Vx and Vy are perpendicular to each other. Yeah, so you can use the Pythagoras formula to find the speed. So the square root of the square of the horizontal component of velocity plus the square of the vertical component of the velocity. That's the speed. What about the direction? Now the direction, we usually use angle to describe direction. Now in this case, the velocity itself actually makes an angle of, let's say, theta with respect to horizontal. So then we can find theta. Now again, this V here has two components, the Vy as well as the Vx. So then we can find theta by using tan inverse of Vy over Vx. Now I want to remind you though that it's best to use absolute value, because you see that here the object is on its way up, so the angle is above the horizontal axis, right? So both Vy and Vx positive. However, let's say that at this particular instant, now if I try to draw the tangent line at this point to describe the velocity, now you can see that this velocity makes an angle to horizontal, but this angle is below the horizontal. Yeah, so again it has Vy and Vx. Now in this case, the Vx still positive, but the Vy would be negative. So then, in order to avoid confusion, I think it's better you just take the absolute value of Vy and then divide by Vx and then find the inverse. Now in this case, in order to distinguish this angle and that angle, you can add description to your answer, like the angle of velocity factor is theta degree below the horizontal axis, or in this case the angle of the velocity factor is theta degree above the horizontal axis. I will show you some common questions that appear in a typical projectile motion problem. Now one of the questions that you will see, some of the questions you will see here will be like the basic standard questions. I'm not gonna delve into like a more complicated questions. We probably will have the time to do that in the problem solving video. But these are just some standard questions that appear in the projectile motion question problem. Yeah. Okay. So one of the things that usually asked here is the idea of the time to reach maximum height. Now remember, due to gravity, the particle will first it will start going up, and then vertically it will slow down, and then later it will reach maximum point vertically, which is the maximum height. We want to calculate how long does it take to reach maximum height. And second is obviously the maximum height itself. Okay? And also, we will also talk about the flight time. The flight time is simply the time when the particle is airborne which is actually related to the first quantity. Yeah, and once you get the flight time, you also want to find the range. Now, range here is simply the horizontal displacement of the particle once the particle reaches the same initial vertical position, which means that, let's say that the initial vertical position is at 0. So when it moves up and then when this maximum, it will go down again. When it go down, it will reach the same vertical position as the initial. When that happens, what is the horizontal displacement? That is what we call as the range. Yeah. Okay. And then we will also discuss about some notable cases. Yeah? Some notable cases. Okay. Now let's start about time to reach maximum height. Now, you can see that when you throw it upward, yeah, as we mentioned before, the horizontal motion is fixed, meaning that it has a constant value. But the vertical velocity, as we discussed before, Vy is equal to u sine alpha minus gt. So then you can see here, u sine alpha constant, g constant, the t is increasing. So t is like the time variable. Yeah. So it increases in time. Now as time goes by, the Vy will become negative. Now again, we assume here that the alpha is the angle between the initial velocity with respect to the positive horizontal axis, and we assume that it's above the horizontal axis. So then this is going to be positive, okay? And g is 9.8, and t is the time it starts from 0. Yeah. Now as time goes by, this value of Vy will decrease. In fact, at one point it will become 0. Now when it becomes 0, it stops momentarily only in the vertical direction. Yeah. Remember, not in the horizontal, because in the horizontal it's always fixed with constant velocity of u cos alpha. But vertically, it will stop in the vertical direction at this particular instance. Now after that, you can see that the vertical component of the velocity will become negative. Now it makes sense here because you see that on its way down, the Vy is pointing downward. Yeah, so it's negative. So in order to find the time to reach maximum height, we only need to find the time when Vy is 0. Okay? So the condition for this is Vy equal to 0. Now we can find the time using this formula. So then set Vy equal to u sine alpha minus gt equal to 0. So from here, u sine alpha minus equal to gt, and the t is equal to u sine alpha over g. Yeah. Okay. So again, we see that the time is equal to u sine alpha over g. Now before I continue further, I just want to remind you again what alpha means. Yeah? So alpha again is the angle between the initial velocity vector and the positive horizontal axis. In some problem though, the alpha given is not this angle, but maybe this angle. Now if the angle used is this one, if this is angle given as alpha, now what you can do is you can find the horizontal one. Yeah, so then you just need to subtract whatever the value of alpha given here, subtract it from 90 to get this angle. So remember, this equation is valid if the angle defined as the angle between the velocity vector, in this case the initial velocity vector, and the positive horizontal axis. Horizontal, not vertical. Yeah, so please keep this in your mind. Yeah. Okay, so then the time here, as we mentioned, is u sine alpha over g. Now, once you get the time, this is the time to reach maximum height. So what is the height? What is the maximum height itself? Well, maximum height is related to vertical position or vertical displacement. Now, remember that earlier, I erased before, but earlier I wrote that the vertical displacement is equal to u sine alpha times t minus half gt squared. So this is general for any time, any value of t. But at the time when it reaches maximum height, the time is not arbitrary. It's actually given by this. So if we substitute this particular value of t here, then it only makes sense that the displacement will refer to the maximum height itself. Right? Okay, so let's do this. So that in this case, the h maximum equal to u sine alpha times u sine alpha. So what I did here is I substitute this arbitrary time with this particular value of time, which is the time to reach maximum height. And so minus half g u sine alpha over g square. And then let me just I don't have to write detail. You can actually do the algebra yourself, but then the final answer is going to be u square sine square alpha over 2g. So this is the maximum height. Yeah. So h maximum is u square sine square alpha over 2g. Now I want you to understand though that even though this formula look like not too difficult to memorize, you're not supposed to memorize it. Yeah. So what you need to understand is how to find the time to reach maximum height, which is given by this condition, Py equal to 0, and also how to find the maximum height itself. So these two formula, even though I highlighted them, you actually encourage not to memorize it, because memorizing this is actually gonna obscure your understanding in many ways. Yeah. And in fact, if you start your learning, your physics learning by memorizing formula, other than the basic one, of course, it will be cumbersome, because there's so many formula that you can derive from one case that when we talk about certain situation and condition. Here we're trying to find the time to reach maximum height, and then there will be more of this. It's not something that I encourage you to do, and actually it's probably the wrong way to learn physics. So yeah, so what I'm showing here is just how you can obtain this quantity based on the condition. So the condition is the one that you need to sort of remember and understand why. Now let's talk about the third one, which is the flight time. Now the flight time is again, as I mentioned, is the time when the particle is airborne, meaning that it's on the air. Now due to the symmetric nature of this motion, the time to reach maximum height is simply the time from here to here. So this is like, you can see, it's halfway horizontally to the air. Yeah. So then the time to reach the initial vertical position again, or maybe the ground, here, would be twice as much as the time to reach maximum height. So that in this case, flight time is twice the time to reach maximum height. Yeah. So in this case is equal to 2u sine alpha over g. Again, I highlight this formula not for you to memorize it, but rather to for you to understand the derivation. Okay. Now what about the range? Okay, range, as I mentioned, is the horizontal displacement of the particle once the object reaches the initial vertical position again. So then it starts from a certain vertical initial position, which we can call it as 0. Let's say this is 0, and then it increases, and then it decreases again, and we will reach 0 again. It doesn't have to be 0, but probably easier to understand. Yeah? So the initial vertical position is say, let's say 0. So it's the you can see that when the particle move up and then down again, the vertical motion will reach the same value as the initial. Yeah. Now when that happens, what is the displacement? What is the horizontal displacement? Now, so in this case, what we need is to find the horizontal displacement. Now, we already know that the time to reach the initial vertical position again is the flight time, which is twice of the time to reach maximum height. So in order to find the range, we look at the horizontal motion, which is the horizontal displacement, as I mentioned. Remember, the equation is x equal to ux times t equal to u cos alpha times t. Now this t is in general variable, yeah, so it can be arbitrary. But in the case to find the range, as I discussed before, it's just equal to the flight time. So substitute the flight time here. So u cos alpha times 2 sine alpha over g, and it's going to give you 2u square sine alpha cos alpha over g. So that's the range. Yeah. Range. Now, actually, again, as I mentioned, even though I highlight this equation, you're not supposed to memorize this. It's about how you derive it and how you understand what that is and how to obtain that variable from the problem. Yeah, analyzing the problem. Now, there are some notable cases in a projectile motion problem that I want to discuss. Now, one of the notable cases is, imagine that you have this. Yeah? So you have, let's say that an object that is rolling, yeah, at the end of a cliff or a building that is initially moving with a initial velocity that is wholly horizontal, meaning that there is no vertical component. So in this case, this is the case when the alpha is 0. So when the alpha is 0, then ux equal to u cos 0 degree, which is u, and uy is u sine 0 degree, which is 0. Yeah, so then when the ux is equal to u and uy equal to 0. Now, usually a question asking you to find the height of the building, and also once the particle hit the ground, which is the base of the building, what is this distance, the horizontal distance from the foot of the building, from the base of the building, right? Now, in this case, again, alpha is equal to 0, so the angle between the initial velocity vector and the horizontal is 0. Yeah, so then the entire u is equal to ux, or you can say the other way around, but uy is 0. So the uy 0 means that initially the the vertical component of the initial velocity is 0. So in order to get to find the time in order to calculate x, actually, you know what, the h or the height usually given. Yeah. So you want to find this x. What is the horizontal displacement of the particle from the base of the building? Now, in order to do that, let's analyze the vertical motion first. Yeah, the vertical motion, here you can use the displacement. So y equal to uy t minus half gt squared. Now the y is the vertical displacement, and in this case, once it reaches the ground, y is actually minus h, because it's h meter below the initial position, and the uy is 0, so 0 and this. Now from here, you can actually solve to find the time to reach the ground, So the time to reach the ground is simply 2h over g, square root of 2h over g. Now once you find this time, then horizontally we can find the displacement by substituting this t value with the equation for x, for the horizontal displacement. So the x here would be ux times t. So that this particular this particular t is that, and the ux is equal to u in this case. So u root of 2h over g. So this is one of a notable case that in which the alpha is 0. Okay. Now, the other case that you might want to we might want to consider here is when the alpha itself is negative. In other words, not negative. What I mean is that the alpha is below the horizontal axis. Let's say that from a certain height above a building, the particle is actually thrown like this. So the trajectory look like this, but the velocity is, this is the velocity. This is the initial velocity factor. Okay, so this is u and this is alpha. Now you can see that the alpha is now below the horizontal axis. So if that's the case, then you should expect that the equation for y is still uy p minus half gt squared. But then the u sine alpha is going to give you negative. This is going to be negative because the alpha is below the horizontal axis. When an angle is below horizontal axis, we assign a negative sign to it. So like if this is 30, then sine minus 30. Okay. Now obviously these are just some something that you will some notable cases that you will see, but it's not the entire the whole story. In order to learn more, to understand more, you need more problem solving, which we will do in the next video. So I hope this video helps you understanding projectile motion, and thank you for watching this video. Please comment, like and subscribe this channel. I'll see you again in the next video.